Hi guys, welcome to the fifth section, using advanced operators and techniques in RxPHP. In this section, we will start with different types of advanced operators. We then move to error handling in RxPHP operator chain. Next will be observable create method, call stack length, and event loop scheduler. After that, we will see unsubscribing versus completing observable. Finally, we will see writing custom directory iterator observable. Now we move on to the first video of this section that deals with different types of advanced operator. In this video, we are going to take a look at zip, materialize, and dematerialize operator. The zip operator is similar to the fork join observable. The main difference is that it internally stores all emissions for each source observable in a separate queue, and then re-emits their values when all sources have a value at a specific index. Let's understand the code. There are 3 source observables. Each of them emits a different number of items. Then the zip operator emits an array of values only when all the sources have emissions at the same index. So we know the debug subject will receive only 2 items because the OBS2 observable emits only 2 items. In other words, the zip operator can't make the third emission because it doesn't have a third value for the second OBS2 observable. Let's run it. As you can see, the output contains only the first 2 values for each source observable. We can have a look at another and more complicated example that stimulates a synchronous emission from multiple source observables. Each source observable emits with a different interval. The zip operator will have to emit according to the slowest one, which emits every 1000 milliseconds. Values for the rest of the observables are then stacked internally in queues. Now we run the code. Here's our output. As you can see, we're actually not losing values. All values that weren't remitted yet are kept inside the zip operator. Let's end the process. Here's the code example where we'll see what the materialize operator actually does. This is just a range observable that emits 3 values and then sends complete signals. The materialize operator converts each signal into an object. Now we run the code. We can see the debug subject received 5 signals in total. The first 3 are just numbers emitted by the source range observable. Then follows the complete signal from the source wrapped as well. After that, another complete signal, but this time emitted by the materialize operator itself. Now let's have a look at another example where we emit an error. In the code, we are focusing one error signal among normal emissions. The materialize operator wraps the error and then calls complete. When we run this example, we will see that the wrapped value 4 never arrived in debug subject since it has already unsubscribed because of the complete signal. Now let's run it. The wrapped value 4 is not arrived. Materialize wraps signals with a notification object. There's also the exact opposite operator called dematerialize. And, of course, we can use these 2 operators independently of each other. We have an observable chain that needs to emit multiple errors, but it can't decide which of these are severe and need to be propagated further down the chain and which can be safely ignored. In a normal observable chain, the first error could cause immediate unsubscription. With clever usage of notification objects and the dematerialize operator, we can let the error pop up when we want. Let's take a look at the code. Here we generate a series of 9 numbers. Every third number is then converted into an error notification. The errors aren't important and can be safely ignored. But the 6th number is different, and when it appears, we always want to signal an error. The code generates multiple error signals and wraps them with notifications. It uses materialize at the beginning to convert all values to notifications. Then, inside the map operator, we unwrap all notifications with their accept method that propagates their value to the appropriate callable. This way, we can see its value and just return it as it is, or eventually return on error notification instead. Now we run it. Here's our output. This is what we wanted to get. None of the errors actually did anything, and they were all emitted as a normal on-next signal. Note that instead of number 6, we have a logic exception. Now the last thing is to filter out all the errors that are unimportant for us. This means all errors except the signal logic exception. Now let's take a look at another code. Here we have prepinned the filter and dematerialize operators before the subscribe call. We have to use dematerialize to turn notifications to their respective signals. Let's run it. All the other errors were ignored by the filter operator, and the only one that was preserved and unwrapped with dematerialize is the logic exception. This method of handling errors is obviously a hack that we typically don't want to do, But it's good to know that even this is possible with RxPHP out of the box, without creating custom observers or observables. In this video, we have learned different types of operator.